Imagine standing at the base of Mount Etna, Europe's most active volcano, as the ground trembles beneath your feet, and a faint rumble echoes through the air. Scientists have uncovered something unsettling here. Mysterious fractures splitting the earth, defying everything we thought we knew about volcanoes. Could these cracks be a sign of a global volcanic domino effect, where one eruption triggers chaos across the planet? Let's dive into the heart of Sicily, where Mount Etna looms like a sleeping giant. This volcano isn't just a local legend, it's a geological powerhouse that's been erupting for over 500,000 years. It is the kind of place where molten lava paints the night sky and ash clouds can ground flights across Europe. But recently, researchers have noticed something strange: fractures or cracks forming on Etna's flanks that don't fit the usual volcanic playbook. These aren't your typical earthquake faults, or the kind of cracks you'd expect from magma pushing up from below. They're deeper, wider, and more unpredictable, almost like the mountain is splitting apart in slow motion. So, what's causing these fractures? To understand, we need to zoom out and think about how volcanoes work. Picture Earth's crust as a giant jigsaw puzzle, with pieces called tectonic plates floating on a sea of molten rock. When these plates grind against each other, they create stress, and volcanoes like Etna are often born at the edges where this stress is highest. Etna sits on a unique spot where the African plate is sliding under the Eurasian plate, a process called subduction. It's like one tectonic plate is diving under another, creating intense pressure that fuels Etna's fiery outbursts. But these new fractures suggest something else is at play, something that's got scientists scratching their heads. One theory is that Etna's fractures are tied to its own explosive history. Over centuries, the volcano has erupted thousands of times, spewing lava, ash, and gas. Each eruption reshapes the mountain, piling new layers of rock on its slopes. Imagine stacking pancakes on a plate that's already wobbling. Eventually, the whole stack starts to slide. Scientists think Etna's eastern flank is doing just that, slowly slipping toward the sea. This movement, called flank collapse, creates fractures as the mountain's weight pulls it apart. In 2018, a magnitude 4.9 earthquake hit Etna's eastern side, and researchers found that these fractures widened dramatically afterward, hinting that the mountain's own instability could be to blame. But here's where things get wild. What if Etna's fractures aren't just a local problem? Could they be part of a bigger global pattern? Volcanoes don't exist in isolation. They're connected through Earth's crust, like a network of pressure points. When one volcano erupts, it can send shock waves, literally and figuratively, through this network. Think of it like dropping a pebble in a pond. The ripples spread far and wide. In 1991, when Mount Pinatubo in the Philippines erupted, it didn't just devastate the local area, it cooled global temperatures for years by pumping ash and sulfur into the atmosphere. Could Etna's fractures be a warning sign that other volcanoes are feeling the strain too? Let's talk about the domino effect. Scientists have long studied how volcanic activity in one region can influence others. For example, in 2010, Iceland's Eyjafjallajökull volcano erupted, grounding flights across Europe. But what's less known is that its eruption may have triggered subtle changes in nearby volcanoes, like Katla, which started showing signs of unrest shortly after. The idea is that when one volcano erupts, it can shift pressure in the crust, like squeezing one end of a balloon and watching the other end bulge. Etna's fractures could be a signal that stress is building not just in Sicily, but across the Mediterranean, where other volcanoes like Vesuvius and Stromboli are also active. Now, let's add a fun fact to put this in perspective. Did you know that Mount Etna produces so much lava that it could fill an Olympic-sized swimming pool every few days during a big eruption? That's a lot of molten rock reshaping the landscape. But all that lava adds weight to the mountain, which could be contributing to those mysterious fractures. It's like Etna is carrying too much baggage, and the ground is starting to crack under the pressure. Another piece of the puzzle is climate change. You might be thinking, wait, what does climate have to do with volcanoes? Well, stick with me. As global temperatures rise, glaciers and ice caps are melting, especially in places like Iceland and Antarctica, where volcanoes are capped with ice. This melting reduces the weight pressing down on the crust, allowing magma to move more easily. It's like taking the lid off a pressure cooker. Things can start bubbling up. While Etna isn't covered in ice, changes in sea level and groundwater from climate shifts could subtly affect the pressure in its magma chambers. Some scientists wonder if these global changes are making volcanoes like Etna more prone to fracturing. But let's not get too apocalyptic just yet. The idea of a global volcanic domino effect sounds dramatic, but it's not like every volcano is about to blow. The key is understanding how stress travels through Earth's crust. For example, in 2011, Japan's Tohoku earthquake, a massive 9.0 on the Richter scale, triggered small quakes near volcanoes thousands of miles away. This shows how connected our planet's geology is. If Etna's fractures are part of a larger stress release, it could mean other volcanoes are feeling the squeeze. But predicting when or where the next eruption might happen is like trying to guess the next note in a song you've never heard. So, what's the worst-case scenario? If Etna's eastern flank keeps sliding, it could lead to a catastrophic collapse, sending a chunk of the mountain into the Mediterranean Sea. This happened in Hawaii millions of years ago, when part of a volcano collapsed and triggered a tsunami that swept across the Pacific. If Etna did something similar, it could send waves crashing into coastal towns in Sicily, Greece, or even North Africa. But don't panic. Scientists are monitoring Etna closely with satellites, GPS, and seismic sensors to catch any signs of trouble early. Let's zoom out even further. Earth's volcanoes are part of a global system, and Etna's fractures might be a clue to how this system is shifting. The Pacific Ring of Fire, a horseshoe-shaped zone of volcanoes stretching from New Zealand to South America, is home to 75% of the world's active volcanoes. If stress from Etna's fractures is linked to broader tectonic shifts, it could mean more activity in places like Indonesia, Japan, or even Yellowstone in the US. Yellowstone, by the way, is a supervolcano, meaning an eruption there could blanket half the continent in ash. But don't worry, Yellowstone isn't showing signs of an imminent eruption. Still, the idea that Etna's cracks could be part of a bigger puzzle keeps scientists up at night. Here's another analogy to make this stick. Think of Earth's crust as a giant stress ball. When you squeeze one part, the tension shifts somewhere else. Etna's fractures might be the crust's way of saying, "I'm under a lot of pressure here." And when you look at the data, rising CO2 emissions from Etna's vents, tiny quakes swarming its flanks, and those widening fractures, it's clear something big is brewing. But whether it's just Etna throwing a tantrum or a sign of a global volcanic chain reaction, we don't yet have all the answers. What's exciting is how scientists are tackling this mystery. They're using cutting-edge tech, like drones that can fly into Etna's craters and measure gas emissions, or satellite radar that tracks the mountain's every move. These tools are helping us understand not just Etna, but how all volcanoes talk to each other through the Earth's crust. It's like eavesdropping on a conversation between giants. So, where does this leave us? Mount Etna's unexplained fractures are more than just cracks in the ground. They are a window into the restless nature of our planet. They remind us that Earth is alive, constantly shifting and reshaping itself. Whether these fractures are a local quirk or the first domino in a global chain reaction, one thing's clear. Our world is full of surprises, and volcanoes like Etna are the storytellers. The next time you hear about an eruption or see a headline about Etna, ask yourself, is this just one mountain's drama, or is the whole planet about to change the script? Keep watching, because Earth's next chapter is still being written.